Good afternoon, ladies and gentlemen. Today we are going to be evaluating expressions. And so we get to plug numbers into the variable numbers, or letters, excuse me, and solve. So it's kind of like a little puzzle, I think. Another reason I love algebra. I know, I'm weird. Okay, so we are going to, so every time you see the words, evaluate each expression for the given value of the variable, all it means is solve. Plug the number in and solve. So I just wanted to make that clear. You don't need to copy that down, but you do need to remember it. Oh, speaking of remembering, I forgot to have you write 10.2 evaluating expressions in your table of contents. So please do that with the appropriate page number, because I think both classes are off. So you just go to your notebook and coordinate that you have the correct page number in your notebook. Okay. All right, so we are going to be plugging in the letter, or the number for the letter. So 16n, which is 16 times n, and we're going to plug in the 8 where the n goes. So it will look like this, 16, and then we'll put the 8 inside parentheses, which also means multiply. So when we multiply, oh sorry, guess what? Wake up, Mrs. Rush. I get to use my eraser. Okay, so back up the truck. Guess what? I wrote this problem incorrectly. Well, we can do it this way. It's all right. But from my notes, I wrote it incorrectly. So here, I'll go back and rewrite it again. So 16n is 16 times n. And when we plug n in for 8, we have 16 times 8. And when we multiply 16 times 8, we get 128. I don't want to take your time up by me multiplying because you guys know how to multiply. Okay? And so then that would be your answer. All right, so we also have 6k. And so k equals 1/3. So we're going to do that the same. Everybody always tends to freak out when you get a fraction. It's just another number. Okay, you just deal with it just slightly different. Okay, so 6k will look like this. 6, we plug 1/3 in for k, just like that, which will equal 6 over 3, because we multiply it that way. And when we reduce to simplest form, we get 2. The answer is 2. Okay, some more examples. We have 6.5 minus n. So here's an example with decimals. And oh look, I forgot to put a decimal, but I will put it in when I solve it. So this is actually 6.5 minus 1.8. So that should be a point right here. Sorry guys, I forgot to put that in there. Okay, I like to do my decimals vertically. So I'm going to go 6.5 minus 1.8 that way. And when I subtract and I borrow and I do all that, here, let me just do it really quick. And we bring down the decimal because we lined those up. Okay, and we have 4.7 is the answer. Don't forget to line up your decimals. All right. Okay, so we have 4x. 4 times x would be 4 times 8. Oops, sorry. Which equals 32. Okay, now the one I messed up that I didn't do, I do want to do it. So I'm just going to do one similar right here. Okay, so we have 21n, and we're going to have n equals 3. Okay, so 21 over 3, which would be 21 divided by 3 equals 7. Okay, so I just wanted to do a division one in here as one of your samples, even though it's fairly simple. Okay, let's move on. All right, now we're going to be using order of operation because we're going to be doing multiple operations. So and all we're doing is we're plugging the number in where the letter is. That's all we need to remember. So we have, let's rewrite the problem. We have 4, and I'm going to plug the 7 in where the x is, minus 7 minus 4. Okay? I have to do what's in the parentheses because that's what PEMDAS says. Parentheses comes first. So we have 4 times 3, and then I can solve it, equals 12. All right, let's try the next one. We have 4x, but I'm going to put my x in parentheses, minus 4. Now notice it's written exactly the same as the one above it, except there are parentheses above. Now we're going to see what a big difference parentheses makes when you put it around numbers, multiple numbers at one time. Whoops. Okay, so we plug the 7 in, so we have 4 times 7 is 28, minus 4 equals 24. So you can see that 24 and 12 are very different numbers, but it all depends on where you place the parentheses or where you don't use parentheses. Okay, so make sure that you are careful about those. All right, moving on. Okay, now we have multiple variables and no constants. So let's plug, but we can still do it, so we're going to plug our numbers in. So we have w minus x plus y. And we know what w and x and y are. So we're going to plug in a 6 here, minus 5 plus 3. Okay, so we have 6 minus 5. We're going to do PEMDAS and go left to right. 6 minus 5 is 1, plus 3 equals 4. All right, that was easy peasy, right? Okay, let's do our next one. We're going to plug the 9 in where we see the x's, so we have 9 squared minus 9. Okay, so we have 9 squared is 81, minus 9 equals 72. Okay, see, isn't this fun? It's like a puzzle. See, math can be fun. All right, we're going to work on a word problem, and you do not need to write the word problem out. I just put it in here so you could read along with me. A scientist measures the air temperature in Death Valley and records 50 degrees Celsius. The expression 1.8 C plus 32 gives the temperature in degrees Fahrenheit for a given temperature in degrees Celsius. Find the temperature in degrees Fahrenheit that is equivalent to 50 degrees Celsius. Okay, so we said that Celsius, that he was measuring 50 degrees. So we know that C equals 50. All right, and they also told us the expression to use up here, 1.8 times Celsius plus 32. So we're going to do that. We'll have 1.8, let me just write it out first, C plus 32. All right, now let's plug our numbers in. We have 1.8 times 50, that was Celsius, plus 32. Now we have to do PEMDAS, so we're going to do 1.8 times 50. When I multiply that out, I got 90, plus 32 equals 122 degrees, and I would not want to be there in Death Valley at that time. So we know that 122 degrees Fahrenheit, excuse me, is equivalent to 50 degrees Celsius. All right, sorry, it's very difficult to write with this pen. Okay, moving on. One last one. This is a short lesson, you guys, you lucky ducks. Okay, one more word problem, and again, you do not need to write this in your notes. You just need to follow along with me. Okay, the expression 6x squared gives the surface area of a cube, and the expression x cubed gives the volume of a cube, where x is the length of one side. Okay, remember cubes have all the sides are exactly the same. All right, so find the surface area and volume of a cube with a side length of 2 meters. So each of the sides are 2 meters tall and 2 meters wide. All right, so for the surface area, the formula is 6x squared. And we said that x is 2. So we're going to do 6 times 2 squared. Well, PEMDAS tells us we need to square the 2 first. So we're going to go 6 times 2 squared, which is 4. And that equals 24 and meters squared. Because each time we're doing, because when we multiply the 2 by the 2, we're also squaring the length, the measuring length, which is meters. So it's meters squared. All right, let's try volume. Volume equals x cubed, length times width times height. Okay, but in a cube, they're all the same size, so it's just cubed. So when we plug in the side, 2 cubed, we get 2 times 2 times 2, which is 8, and then that's meters cubed because we're multiplying it 3 times. So you have to have that cubed in there. All right. Okay, so tomorrow morning we will do a bunch more samples, and we will see you then. Have a great afternoon.